Hello, in this labor economics video, we're going to look at straight time pay, premium or overtime pay, and something called straight line equivalent pay. We'll start with straight time pay. Here's a worker's utility function. It is a function of consumption and hours of leisure, L. The marginal utility of leisure equals C. If we just take the partial derivative of this utility function, we'll get back C. And we're going to get the marginal utility of consumption, measured in dollars, and that is going to equal L. Again, if we take the partial derivative of the utility function, but this time with respect to C, consumption, we'll get back L. The market wage is $20 an hour, and we're going to have non-labor income equals 0. We're going to assume that the total time, T, of 16 hours per day are available for work and leisure. So the person has 16 hours a day to allocate between work, hours of work, and hours of leisure. So we'll form the constraint. T, the total time available, equals hours of work plus hours of leisure. So we're going to plug in 16 for T. And then we're going to just solve for H here. So hours of work will equal 16 minus hours of leisure. The level of consumption for the worker is going to be the wage times hours of work. So where we have H, we're going to replace that with 16 minus L. And then we're going to replace the W with the wage that we have on top here of $20. And just multiply this 20 through. We have our constraint. Next, we'll form our utility maximizing condition, where we have the marginal utility of leisure divided by the wage will equal the marginal utility of consumption. And making our substitutions into this formula, we saw that the marginal utility of leisure is C, the wage is 20, so that's what we got on the left-hand side, and that'll equal the marginal utility consumption, which is just L. We're going to solve this for C, so multiplying through by 20, we have the following, and now we got two C equations, and we're just going to set both of these equations equal to one another. This 20L will be set equal to this 320 minus 20L. And now we're going to solve for L, adding 20L to both sides and dividing through by 40. The consumer will take 8 hours of leisure. And since there's 16 hours in a day to allocate between work and leisure, H, as we said, is 16 minus L. So hours of work is going to be 8, 16 minus hours of leisure. And in terms of the consumer's level of consumption, making $20 an hour, working 8 hours, $160. And let's get the utility level. Utility is C times L, where C is 160, and hours of leisure, we solved up here is 8. So this worker will have utility of 1,280. Let's move to premium or overtime pay. The worker will earn time and a half for each hour worked after 8 hours of work. So if the market wage is $20, the premium pay, again for any hours of work in excess of 8, will be $30, 20 times this 1.5 time and a half. So our utility function, once again, our marginal utilities. So here's a straight time constraint, the equation we saw in the last slide. And if we were to graph this equation, notice the vertical intercept is 320, which I have graphed here, and it has a slope of minus 20, which is just minus the wage. So it's going to look like this, a straight line here. Horizontal intercept is 16 hours of leisure. Vertical intercept is 320. With the time and a half, any hours worked in excess of 8. So right here, if the person takes 7 hours of leisure, that means they're working 9 hours. If the person takes 6 hours of leisure, that means they're working 10 hours and so on. So the person works more hours as we move closer to the origin here. And you can see here that with overtime pay, you're getting paid now $30 an hour. So the slope of the budget line will change in this section. So let's get more specific. So the premium constraint will actually equal the following. The vertical intercept will be $400, and I'll show you how to get that in a minute. And the slope is going to be 1.5 times, this time and a half, of the old slope. So the old slope here was minus 20. Now, because of the time and a half pay, the new slope will be slightly steeper, 1.5 times steeper. And so this will be our premium constraint, premium overtime pay constraint. So where's this $400 coming from? So the first 8 hours of work, the person would get paid $20 an hour. Any hours of work in excess of that, and it's possible to work 8 hours of overtime pay, 8 times the time and a half, or $30 an hour. Adding this all up, we get the $400, or the vertical intercept. So if the person worked 16 hours a day, the person would make $400, thus the vertical intercept. All right, so incorporating that into our problem. So the same marginal utilities, the new overtime pay constraint, setting up the utility maximizing condition, making our substitutions here. W now is 30. Solving for C, and setting the two C equations equal to one another. We're going to solve for L. So adding 30L to both sides and now dividing through by 60. The utility maximizing hours of leisure is 6.67. Utility maximizing hours of work is going to be slightly larger than before, 16 minus the 6.67, or 9 1/3 hours of work. And now let's get our level of consumption. So all I'm going to do here is take our constraint here and plug in the L of 6.67. And the consumer will be able to afford almost $200 of consumption spending. And utility at this 199.9 and leisure at 6.67 is 1,333.33. So the worker's utility increases from 1280 to 1333.33. In terms of a graph, so with straight time pay, the worker maximized utility with 8 hours of leisure and 8 hours of work. And here I have an indifference curve tangent at that point. With overtime pay, the worker is going to move to this point up here with 6.67 hours of leisure, or 9.33 hours of work, and able to afford $199.9 of consumption goods. There would be an indifference curve tangent at that point, but I didn't want to get this diagram too cluttered, so I didn't draw it. But again, at this point here with overtime pay, the consumer gets on a higher indifference curve, utility goes up. All right, let's talk about straight line equivalent pay. This is going to be an hourly wage that provides the same level of income or consumption as premium pay for the same number of hours of work. So with premium pay, the hours of work were 9.33, and we found this level of consumption. The straight line equivalent pay would be taking this consumption level and dividing it by the hours of work. You get a straight line equivalent pay of $21.43. In other words, if you work 9.33 hours at $21.43, you'd be making the same level of income and be able to afford the same level of consumption. So does a worker prefer premium pay to the straight line equivalent wage of $21.43? So does a worker prefer $20 an hour and then $30 an hour for any hours worked after 8? Or would the worker prefer just to earn $21.43 regardless of the number of hours worked? So let's solve that. So utility function, marginal utilities, the straight line equivalent wage or pay, the constraint, okay, multiplying through, simplifying that up, setting up our utility maximizing condition, plugging in the wage, but this time of 21.43, solving for C, setting our two C equations equal to one another, and now solving for L. The worker would choose 8 hours of leisure, meaning 8 hours of work. The consumer would, or the worker would be able to afford $171.44 of consumption spending, and the utility level here would actually be greater than under the overtime pay. All right, that's my example.